Okay, so this is problem 4.5.45. Directions are that they ask us to solve, and they're giving us this exponential here. And they did also say in the directions that they want us to not round during the problem, but then round your final answer to 3 decimal places. Okay? All right, so what we're going to do, we're solving for x, and x is in an exponent. So what we need to do first is just get it out of the exponent. The first thing we should do here is just cross multiply. So I can take this numerator, multiply it by that denominator, and this numerator and multiply it by that denominator, and I can set those things equal to each other. So this is going to be 11 times 10 to the x minus 11 times 10 to the negative x, and then 1 times this just gives me 10 to the x plus 10 to the negative x. Okay. Now, what I want to do at this point is I want to collect like terms, and it might not seem like it, but this 10 to the x right here is a like term with this 10 to the x over here, and this one is a like term with this one. Notice that this 10 to the x has a coefficient of 11, so this is just, you want to treat this 10 to the x just like a variable. So over here, if I were to subtract this 10 to the x and bring it over here, the coefficient on this 10 to x is actually a 1. So this is like I'm subtracting 1 times 10 to the x. Okay. And you know how this goes. If you were to subtract 11x minus 1x, you would get 10x. We're doing the same thing here. It's just that we're treating this 10 to the x like our variable. So this becomes 10. That's the 11 minus the 1 gives me that 10. And then our variable here is that 10 to the x. We can think of it that way. And then I want to do the same thing here, subtract 10 to the negative x. This is minus 1 times 10 to the negative x. So that gives me negative 12 times 10 to the negative x equal to 0. Pardon me. Okay, so at this point we're looking to solve, and there's this trick that we can use, which is when you have a negative exponent here, you can actually factor it out. So if I pull out 10 to the negative x, then I have to think about what do I need right here so that when I multiply that by 10 to the negative x, I get this back. And really what I need is I need 10 times 10 to the 2x. Okay, now the way that I'm getting that is this 10 is that 10, and I'll need that in order to get it back. And then my exponent here, when you multiply like bases, this 10 times this 10, negative x plus 2x would actually give me a positive 1x. When you multiply like bases, you add the exponents, so that's where this 2x is coming from, because negative x plus 2x would give me that positive x right there. Okay, and then what I need in order to get this back is just a minus 12. Okay, and that's set equal to 0. Okay, so what I'm looking at now is setting each of these pieces to 0 and then solving. Okay, and you know this 10 to the negative x here, that's just, you're not going to get an answer for that. There is no x that we can plug in and get 0 out of this. We have 10 to some number. It's either going to be a big number or a small number, but it's going to be a number other than 0. Okay, so this is just not going to give us any solution. This one over here, though, if I want to solve for this x, I'm going to add 12 to both sides. I have 10 times 10 to the 2x equaling 12. And then I'm trying to isolate the x, so let me divide by 10. Okay. So I have 10 to the 2x is equal to 12 tenths. All right. Okay, at this point, 10 to the 2x equals 12 tenths. At this point, what I'm going to do is I'm actually going to use a natural log on both sides. You could use just a basic log, base 10, whatever you'd like. But I'm going to use the ln, and that's so that I can bring that exponent down. I can use that power rule. So I can take this and pull it down out front, and that moves my variable from the exponent down into a place where I can solve it. Okay. So that gives me 2x times the ln of 10 equals the ln of 12 tenths. And I'm looking for x, so I'm now going to divide by the 2 and the ln of 10 on both sides. 2 and the ln of 10. 2's cancel, ln of 10's cancel. and my x is the ln of 12/10 all over 2 times the ln of 10. Okay, now that's, our exact answer. They wanted an approximation. When you plug this into your calculator, you get 0.039596, and it goes on. They asked us to round to 3 decimal places here. So 1, 2, 3 would put us right here. So if we round that, it's actually going to be 0.040 would be our answer for this problem.